We're on lesson 7 of chapter 3, which is dividing fractions and mixed numbers. So the opposite of what we were doing last lesson, which was multiplying. So we'll divide fractions, then mixed numbers, then we'll do a word problem. We actually don't do much dividing here. We just multiply times reciprocals. And the idea behind a reciprocal is it's the opposite, it's the inverse of a fraction. So the reciprocal of 8 over 1, or 8, is 1 over 8. See what we did? We just switched the numerator and the denominator around. And if you can divide by 16 by 8 and that equals 2, you can multiply times the reciprocal of 8 and get the same answer. So we save ourselves all this dividing work by just multiplying times reciprocals in our lesson today. So we have 2 over 3 divided by 1 over 5. So when we do reciprocals, we always do the second one. We turn this 1 over 5 into a 5 over 1, or we use the reciprocal and then just multiply. So if we write this problem, it would be 2 over 3, and then times now, let's do the reciprocal, so 5 over 1. And then it's just like what we did yesterday, multiply across. 2 times 5 is 10, 3 times 1 is 3. All right, this is an improper fraction, so we have to simplify this. 3 goes into 10 3 times, and then 3 times 3 is 9, so 1 left over, so it'd be 3 and 1/3 for our answer. Let's do this one then. 3 over 5 divided by 6. So just like this 8 over 1 is 8, we can turn 6 into 6 over 1. And then we can multiply times the reciprocal. So 3 over 5 times 1 over 6. Then we just multiply across. 3 times 1 is 3. 5 times 6 is 30. They can be both divided by 3, so that would be 1, and this would turn into 10. So our fraction here, answer, would be 1/10. Now let's do some mixed numbers. So same thing as last time, we convert these into improper fractions. So 4 times 3 is 12, plus 1 is 13. 13 over 3 divided by 2 times 2 is 4, plus 1 is 5. 5 over 2. So never make this the reciprocal. Always only do the second one. So we'd have 5 over 2 to convert. So we'd have 13 over 3 times now the reciprocal, which would be 2 over 5. So 13 times 2 is 26. 5 times 3 is 15. Let's convert that into a mixed number again. So 15 goes into 26 one time. And then there's 11 left over, so it'd be 1 and 11 over 15 for our answer. Let's look at this one then. This one's already a fraction, so we're good. Let's convert this to a mixed number. 7 times 7 is 49, plus 1 is 50. So 50 over 7. So then we're dividing by 50 over 7, so we can multiply times the reciprocal. So 5 over 6 multiplied by 7 over 50. All right, so we can multiply across. Actually, before we do that, I caught something. We can do some simplifying right here. So you can actually cross simplify. So I see a 5 here, a 50 here. I'm going to divide both these by 5 now. That'll save me some work later. So 5 divided by 5 would be 1. 50 divided by 5 would be 10. There we go. So 1 times 7 would be 7. 6 times 10 would be 60. And since I did my simplification first, there's no more simplifying to do for this, so I'm all done. So 7 over 60 would be that answer. Let's do a real-world application then. An average $1 bill stays in circulation for 1½ years. An average $100 bill stays in circulation for 9 years. So how many times longer does the $100 bill stay in circulation? And this is a question. Let's fix that. Thank you. All right, so we have 9 years here. This is only a year and a half. So how many times longer is that? Whenever you solve that kind of problem, how many times does this fit into that? That's division. So we'd have 9 divided by 1½ Let's convert that to an improper fraction. 1 times 2 is 2, plus 1 is 3. So it'd be 9 divided by 3 over 2. So we can multiply times the reciprocal now. So I'd have 9 over 1 times now, And then the reciprocal of 3, 2, which would be 2 over 3. And just like last time, I can simplify now. Let's divide these both by 3. So this would be 3, this would be 1. So 3 times 2 is 6. 1 times 1 is 1. So you could write it over 1, but you can just write 6 for your answer then. So this would be 6 times longer.